Action. Okay, we are going to be looking at the 30, 60, 90 triangle. Mathematically, this is going to be extremely important. It will not help you win the volleyball game. It will not help you in the clarinet concert. In this class, it will be nearly considered essential. All right? Well, the first thing first, and I may ask you to regurgitate this on some kind of test or quiz. You may have to regurgitate this. So I'd like you to draw, and I'm going to draw a triangle which I am attempting to look approximately 30 degrees, 60 degrees, 90 degrees. And you'll remember from your geometry days, if you were to put 30 degrees and 60 degrees in, if it looks sort of close, you're going to have to know this, by the way, so make this quick. For your geometry days, if you make it try to look it pretty good and then put the markings in, that means it is what it is. And just for fun, and you're going to think, wow, this is fun, I am going to just say that this hypotenuse is 18 long. Maybe it's 18 feet, 18 inches, 18 centimeters, 18 miles. It's 18 somethings long. And the answer to the question is absolutely yes. You could do some trigonometry to find those other two sides or those legs of the triangle. Absolutely. However, oftentimes, trigonometry gets you an incredibly accurate answer, but not perfect. And I'm going to look for a perfect answer today. So I want to find out how long this leg, and I'm going to call that the shorter leg, this leg the medium leg, and I'm going to call this the hypotenuse. Instead of like short, medium, long, I'm going to short, medium, hypotenuse, which has to be the long. Well, what I'm going to do, and maybe you're going to do it too, because a lot of you are participating, is draw a congruent triangle right next to it that's actually connected to it. They will actually share that medium side. So it's a congruent triangle, and you will remember all sides and all angles would be the same on congruent triangles. So 60 degrees and 30 degrees. You could almost consider that triangle a reflection over the y-axis if we had a little grid there. Cool. And now over here, I'm going to draw attempted to be the same triangle. It looks a little different, but that's just because you're having eyesight trouble today. And this is supposed to be that same triangle. It's supposed to be that same triangle, and just with sort of the middle line, that middle missing. So that's 60 degrees, and that's 60 degrees, and that's 18. And you will remember that I mentioned earlier on that in this school we do well on our ACT type tests. However, mathematically, the lowest our school scores in these subcategories is in geometry. And because I'm recording this, remember, of course, that's because. Okay, all right, okay. So I keep trying to throw in a few geometry reminders for you to help you. And in fact, those 230 would add up to be 60. The name of this triangle is my little geometry view. It's called an equilateral triangle. It means all the laterals, all the sides are equal. By the way, there's another word. It also could be an angular. Yes, equiangular. Yes, equilateral, equiangular, meaning they're all 18. So all these sides are 18. So this is this triangle. So now I'm going to put the 18s over here. I'm going to put the 18s over here. All right. I would like you to really enjoy looking at this triangle because I'm about to start erasing. So really enjoy looking at it now. By the way, because this is being recorded, you could come back and look at it. But, there. And I hope you were enjoying looking at it when it was there because it is erased. Ooh. Say, how long's that side?
9.
Is it? We had a congruent triangle here. It was 18. We took away exactly half of that. That is exactly 9. All right, Pythagorean theorems, good time. A squared plus b squared equals c squared. I'm going to go just a little bit off topic for just a moment. We're going to clearly simplify that. But I'm going to ask you some questions here. I'm going to teach you a little something you might not have learned. With no calculator. By the way, what is the first square root I try to break into it?
How about square root A1 square root?
Hang on. I'm very good. I want to go from the smallest. We might know the answer, but I'm going to go from smallest to biggest. The first one I should try would be the square root of 4. Square root of 4. Everyone look at this. Any way 4 goes into that. No. It would, for there to be any chance, it would have to be what kind of number? It would have to be an even number. So there's no chance. Now this is really cool. How many of you, by looking at this number, doing a simple calculation, know if 9 goes into it? Did anyone ever get taught the little trick on if 9 goes into something? 1, 2, 3 of you, 4, 5, 6 of you. How many, no way you've been taught a little trick to know if 9 goes into it? All right, first hand up, Josie. What do you think?
If the sum of all the numbers equal 9.
This is really cool. What's 2 plus 4 plus 3? Does 9 go into 9? 9 is going to go into this. This is really cool. Now I'm off topic for just a moment. Goodbye. Off topic for just a moment. All of you. Does 9 go into that? No calculator. What do you do? Add these up. 6, 13, 14, 16, 24, 27, 31. Does 9 go into 31? Does 9 go into this? No. Does 9 go to that?
34. No.
It's 34. Does 9 go to 34? Nope. Let's see. Does 9 go to that?
No. 49.
13, 16, 20, 31, 34, 45. Is this 47?
47.
47. Does 9 go into that?
50. No. 59. No. 63. Yes.
This is so cool. This adds up to be 63. Does 9 go into 63?
Yes. So 7.
Guess what? Guess what? If you didn't know if 9 went into 63, you know what else you can do? What's 6 plus 3? Does 9 go into 9?
Yes.
Cool. So that's just a trick that about 6 of you were taught way back to know if 9, it's called a divisibility rule. Does 9 go into this? Oh, welcome back. 9 goes into that. It sure does. I'm going to try to find bigger ones. After 9 comes what? What's the next bigger square root? 16. Hey, if 4 doesn't work, finish that little statement. 16 won't work. Anyway, 25 goes into this? No. It doesn't end in a 5 or a 0. No, no way. 36. Did 4 work? If 4 doesn't work, no way 36 is going to work. 49. I don't actually know a rule for 49. To 64. If 4 didn't work, 64 is not good. Does 81?
Yes.
Yes. How many times? I got off track on purpose. Now I'm back on the right train. This will be something mathematically you are just going to want to know. You are just going to want to know this. Mathematically, you're going to want to know it. I am calling this short, medium, and hypotenuse. And go from the short to the hypotenuse. What does it look like you simply do? You simply multiply by 2, double it. Multiply by 2, double it. To get from the short to the hypotenuse, you double it. From the short to the medium, take it times square root of 3. Say, if you had the hypotenuse, how could you get the short? Divide by 2, or you could also say cut it in. Cool. To get from the medium to the short, instead of times by 3, you could divide by 3. Say, I think some of you are going to know what I'm talking about. There's 3 of you that are friends, okay? But in that little group of 3 friends, there's sort of one friend that sort of glues the group together. And you're all friends, but if that one friend is gone, the other 2, they get along, but it's sort of weird because they're missing that one that was sort of the central friend. You know what I'm talking about? Yeah. Does that make a little sense? Okay. Well, now turn that great real life story into math, okay? It's really hard to go from the medium to the hypotenuse. It's really hard to go from the hypotenuse to the medium. It's so much better if the short is there. Just like it's a little less awkward if that third friend is there, that one who's sort of the friend of everybody. So I'm not going to make any rules that go from like medium to hypotenuse. We're going to go the long way. We'll go from the medium to the short to the hypotenuse. I'll quit recording. Ready.